Yay! Sorry for the delay, folks. I'm Keith Wright. I'm from One Course Source. I want to talk to you today about looking for patterns by finding them with regular expressions. I like the SCaLE type comics here, but you can see here if you're having Perl problems, I feel bad for you, son. I got 99 problems. So I used regular expressions. Now I have 100 problems. So this is how a lot of people might feel about regular expressions right now. But we're going to try and solve that. Let's talk about what regular expressions are. They are just special strings that are used to search for patterns in text. You're probably familiar with wildcards, but they're much more powerful than wildcards. Instead of just a couple characters, maybe the question mark, asterisk, and square brackets, you'll see a lot more today. You'll find that they're almost everywhere you do programming, and they're available in the shell with a lot of the POSIX compatible programs that you might use. You'll see them referred to in many different ways. A lot of people are too lazy to write out regular expressions, so you might just see RE is one of my favorites. That's the Python module I like to use. Although regx or regexp is a common expression as well. You got to be careful on what you do and don't do with your regular expressions. There's some good things that you can do with them. They're really useful in a lot of applications to validate user input. You want to make sure you get a valid credit card number or a valid date, a phone number, those kinds of things. They're perfect for that. They also, oops, I clicked twice, but I think people might be confused anyways between what's the difference between data extraction and data elimination. With data extraction, you can use regular expressions to extract things from text files, perhaps. Say you get a document, it might have a bunch of different email addresses scattered throughout it. You could easily use a regular expression to capture all of those. You could take the opposite approach and eliminate everything that's in that document that is not an email address, and then kind of distill it that way. So depends on what you're trying to do. Pull out important information or get rid of extraneous information. And lastly, we have search and replace. You can do substitution with regular expressions. So you can go search for, with a regular expression pattern, what you want to find, and then have it be replaced with something else. You can get in trouble using them incorrectly, though. You're really not supposed to do parsing with them. A lot of people try to do that, try and recognize HTML or XML and parse it. There's usually other better tools for that, and certainly that's one of the points I'll make later here. If you were to put up on your web server the ability to search through your website by regular expression, this could just cripple your server. Someone could put in this horrendous, complicated expression and just tie up your server running for hours or even possibly days. So you don't really want to expose these in public interfaces. That could give you kind of a denial of service problem. And as I just mentioned with parsing, but in other cases as well, if there's something better to use, then I'm a firm believer in use the right tool for the job. And in programming, sometimes while you might think a regular expression would work really well, you might be able to just create a procedure that would do the same thing better. Just a sampling of some of the languages where you're going to find regular expressions available. .NET, the regex lib that I'll bring up a little bit later, has a lot of these types of expressions, but you can see C#, Delphi, certainly Java, and JavaScript has native regular expressions. Perl, as you might have picked up from the first slide, largely oriented around these, and they're really easy to use within Perl. And then if you're doing C programming, you'll find that there's this Perl-compatible regular expression library. That's what PCRE stands for. but also in web-based PHP type stuff. And I'll show you a couple examples later with Python and Perl, but Python works real well with these. Ruby, Tickle, PowerShell, and a lot more. So, anyone have any language they use with regular expressions I didn't put up? Okay. From the command line in Linux, some of my favorite tools to use regular expressions with, awk. Sometimes awk can be good to do things like trying to extract columns of information out of data that you have, and using regular expressions to do that can be very helpful. With the find command, you can do -regex and then find your files not just by a solid or fixed name, but by a regular expression. And I'll be doing lots of examples today with grep, which actually, you see the RE in its name, that actually kind of means regular expression. It comes from an original ed command, which is still available in VI, where you type, colon and then G / and then what your regular expression was, and then /P, and it would globally print all the matches of that regular expression. And then lastly, we might talk about sed, the stream editor. There's a lot of good sed one-liners out there. If you want to do something like reformat a document, you can use sed with regular expressions to be able to do that. Now, when we look at these POSIX programs that support regular expressions, it's really important to understand there's really two different types. The basic type, which was kind of the original set, and then later on they expanded with what they call the extended regular expressions. So we're going to be seeing all these characters on slides coming up today. The character classes, where you'll put in square brackets what you want to be able to match. Named character classes, where inside of square brackets you'll find another set of square brackets which has a name like digit or punctuation, where it makes it really simple to match something that you might be interested in. Certainly digits are not hard, but punctuation characters, knowing all of them, might be tricky. But there's a lot more we'll see. There's also the asterisk, which can match 0 or more characters, and the dot, that'll just match 1. Now, caret doesn't really match characters, but it means to match at the beginning of the line or the beginning of the string that you're searching in, which can be really helpful if you want to find a line that starts with some particular expression. So you can proceed that with a caret. And then the $sign you'll see is just the opposite. It's going to be at the end of the line. So if you're searching for sentences that might end in something, or a line that ends with a particular character, that $sign can be used for that. So both caret and dollar don't really match characters themselves, but positions or places where those characters might appear. Now, some of these expressions that you might use are a little tricky to use with BASIC because you have to escape them. The curly brace brackets allow you to specify the repetition, the minimum number of matches that you might want, or the maximum number. And you can omit either one, so you could have at least as many or not more than, as well as do an exact number of matches, like I want to find exactly 5 E's in a row. We'll see more about those. And the backslash parentheses, or parens. If you want to use those in BASIC, you'll have to put a backslash in front of them. They'll allow you to do groupings, and we'll see how those work. Now, for the extended regular expressions, we have the question mark, which will be used to follow an optional character. The plus sign, which means one or more of the previous set of characters. The pipe symbol, which allows you to perform what they call alternation. It's kind of like a logical OR. The curly braces don't have to be backslash when you do extended regular expressions. They're just regular braces. Same with the parentheses. And then whenever you're doing your command with the extended regular expression, it still supports all the basic stuff, the character classes, the asterisk, the dot, the caret, and the $sign. shoot. Sorry, I'm going to back up to that one. Somehow my grep slide got moved around, and I had one that was fixed, but that was on my laptop. Okay, so I want to talk about a tool that's really useful, and probably the way I use regular expressions the most in Linux is by using grep. So you can use grep and you specify your different options, and then you'll have your pattern. And you'll see in the examples that I'll be using, that pattern will be in single quotes, so that like the bash shell or whatever shell you're using doesn't try and interpret the regular expression characters. Grep is going to be interpreting them. And then you can specify your file. Alternatively, you might have a command that has output, a pipe, and then grep with its options and its pattern, and then you don't need a file. Okay, so we'll be looking at grep. Whoops, there I go, backing up again when I didn't mean to. I'll be using it to demonstrate how they work. And by default, when you use grep, it's only going to do the basic regular expressions. There's a command egrep, which oftentimes is just an alias to grep, that when you execute it as egrep, it treats it as if you executed grep -E. So whenever you're using those extended things like the plus or the question mark, you need to use either egrep or grep -E. A real useful option so you can actually see what is really matching is the -- color equals, and then you can specify, or you can just do auto, which is red. -I you can add to make grep case insensitive. -C if you just want to know how many matches or get a count. And -V, I consider it an inversion, that's the way I remember V, or the reverse grep, where it will print the opposite. Instead of the lines that match, it'll print the lines that don't match your expression. Okay, so I just wanted to point out how grep worked before I started showing some examples of it. And we want to see those in the character classes. Character classes, you'll see the square brackets enclosing either a character or set of multiple characters. You can also do a hyphenated range of them. If the first character inside of those square brackets is a caret symbol, then that list of characters that you have, or the range, is negated. One of the problems with trying to use square brackets is trying to match the square bracket itself. So if you're trying to use the square bracket characters to match the square bracket must be the first character inside. Otherwise, if you do not want to match it, it has to be the first character after the caret. It's the second character or the first character after the caret.
Is that just a negation, or can you do backslash and escape it?
You don't need to escape it inside of the square brackets, but it's positional, that it has to do that for you. Let's see, I'm trying to see if my example will show up here. And that's right, that one, for some reason, didn't. So I hope I can get a... No, it's going to be really difficult, unless I can see. Okay, there's John and his desktop. And I'll do echo, quote, and say I have brackets in the text. Yep, brackets left and right. And I'm going to pipe that output to grep and use my character classes, whoops, square brackets are in quotes. Now, to get the right square bracket, we're going to put it as the first character in there. The left square bracket can be anywhere else. I think that's right. So we see grep. The outer square brackets are for the character class itself. Inside, we're going to be looking at matching either a left square bracket or a right square bracket. I think I'll put in a couple other characters just to make it a little more interesting here, like an A and a B character as well. Good. And I don't see in John's shell that it matched that the way that I'd like to see it. Did it? Yeah. So alias grep equals quote grep dash dash color equals auto. That was one of the options. Interestingly enough, that's a default alias in my own shell, but it appears that John doesn't have that. So now we'll try that again. Oh yeah, now you can see the A and the B where they matched. Well, the B's up off the screen here a little bit, but you can see where it literally matched those square brackets in red. So that's kind of nice. And most of my other slides will have the example with the grep. Somehow in transferring it, it got lost. See, there's a empty placeholder where that was at one point. But we'll see those on other slides. So, and back to our show. So we have that single character somewhere inside those square brackets. The caret can negate that list. And the brackets themselves are the trickiest thing to match in there. Otherwise, normal characters like we saw, A and B, are no problem. The hyphen is also somewhat problematic because it can be used to indicate a range of characters. So if you want to match the hyphen character, it has to be either the first or the last character, or it could be the character right after the caret. I'm trying to get to John's shell again. So I'm going to do A hyphen D. Would I not close my quote right? Oh, I added an extra one. Shoot. And the bracket. Good. So hard to type over your corner. That's what I should have, right? Oh, I got it. There we go. So now notice with the hyphen, A through D, it could be any character, A, B, C, D. And you see like it matched the B, the A, and the C, as well as those square brackets. Yes, it does. It will not understand a reversed range. You've got to make sure you put it in the ascending order, not descending. Okay, so getting inside the square bracket, I can put a hyphen in there. And that way, somewhere in my text, if I had a hyphen or a couple, it'll match the hyphen character now. Now the A hyphen D was for that range of characters, but with the hyphen being the last character in square brackets, it is matching it. The other one big thing I want to point out up at the square brackets is the negation. So right now it's matching those characters. How about we not match those characters? So we could put that caret symbol in there. Did that go? Why didn't caret appear? Shift 6. There it is. And so now everything else but any characters A through D, the hyphen, or the brackets would match. We already talked about grep. You see how it's working. You can see how that alias for, or the option for adding color was really nice. Okay, now for literal characters, they will just match themselves. So if you're talking about an alphanumeric character or any non-regular expression character, it just matches itself. You can see how grepping for the caret or the character T, it is case sensitive without that -I option. You can match regular expression characters if you put a backslash in front of them. And someone asked that question inside of the square brackets. You don't need the backslash, but if they're not in square brackets, you do. So you can see here the backslash dot. It's kind of hard to see that it actually matched that dot right there, where the dot is a special character, or looking at the braces there. In basic regular expressions, the braces themselves are not considered regular expressions. You have to put a backslash in front of them. And we'll see more about that when we talk about the braces. Now we're looking at that dot character, or the period, where it will just match one single character. So notice in the first example, I've got some text that I'm searching through, and I'm grepping for, quote, A, B, dot, dot. So we see that it matched A, B, and then two characters, Z, Z. If you want to match the dot itself, we've got that backslash in front of it, which we did just see in the previous example. Kind of the equivalent of the wildcard character asterisk is dot asterisk, where that can be any character, and then the asterisk modifies that, repeated 0 or more times. So in this last example, we see using dot asterisk. It's going to be able to match that entire string. Next, we've got those named character classes. Like we saw earlier, the example digit. Here we have an X digit, which is a hexadecimal digit. And how it could recognize characters, A's and B's, C's, D's, up to F, but not G, H's, and I's, as well as numbers. So in case you're trying to find hexadecimal digits in your text, that character class, X digit's really good for that. There's a ton of these available, as you can see, alphanumeric, just alpha, control characters, digit characters, graph. You can also do kind of case-sensitive stuff with lower and upper, printable characters, punctuation characters, white space characters as well. Now, what's kind of confusing is when you read the man page on grep, it'll say, oh, use this character class, square bracket, digit, square bracket, and you try that and it doesn't work. Remember, there's a doubling up on those square brackets when you're using those, like we see here, or as you can see in these different examples, that there's two left square brackets, a colon, the character class name, a colon, and then two right square brackets. I like the caret character a lot. It's very helpful for finding things at the beginning of something, typically the beginning of the line of text. If it's in those square brackets, it's used to negate the set of characters, which I did a little demo of earlier. And if it's preceded by a backslash, then it loses its special meaning. So in the first example, we see the string xyz dot abzzz, and then trying to match that with grep, caret abz, it doesn't find abz because it's not at the beginning of the string of text. Whereas in the second example, you can see we've got that same text, grepping for caret xyz. Well, since xyz is at the beginning of the text, it finds it there. If you wanted to find a caret in the middle of the string, we can use grep and the square brackets for it. Notice that actually negated, actually, that's the second one here. No, the third one, I'm sorry. This is a negation of XYZ. Oddly enough, it actually finds the caret because the caret is not an X, Y, or a Z. And you can see all the other characters it did not find were X, Ys, or Zs. And And then we have caret, caret, XYZ. So now we have not the caret character or an XYZ. So then it only found the A and B. And then really the last example is finding the caret where it's not that first character or after another caret, that it could actually literally search for that caret itself. Besides the literal characters, just the letters and numbers that I look for, probably the caret and the dollar sign are the two regular expression characters I use the most. Because it's very important when you want to find something at the beginning or at the end of your text, which is how the dollar will work. So notice that if we have that dollar sign at the end of our grep expression, it means that it has to end in that. The text ends in A, B, and 3 Z's. It doesn't end in A, B, and 1 Z, so there's no match there. Whereas the second example, we can see 3 Z's and then a dollar sign means we want to find 3 Z's at the end of the line. A dollar sign that's not at the end of your regular expression is just trying to find that dollar sign character itself. If it's not at the end of your expression, it's just a literal character. And we have a couple of examples of that. As long as it's not the last character, then it's treated as the dollar sign. Yes?
Is that a BRE only?
In basic regular expression, I haven't seen if there's any difference when I try it with extended.
Because in multi-line, I've had instances where I do dollar, and I do new line, and I keep going.
Okay, that is well, that's not extended, that's a modified regular expression. When you put in an option, and it varies in language to language how this is done, you can specify to whatever program you're using that you want the regular expression to not stop matching at the end of one line, but to like go through a whole paragraph or through the entire document perhaps for matches. And then the dollar sign doesn't have any special meaning there. It's just a literal dollar sign.
Oh, really?
Yeah.
So it's the new line that does magic, not necessarily the dollar sign.
Correct. Yeah, there's some kind of interesting caveats on that. So yeah, if it's not at the end normally, and not multi-line mode, it loses its special meaning. One of the really useful ways is to combine it with the caret symbol. If you want to know like the whole line of text is just this, then you can specify starts with that caret, whatever text or regular expression, and then dollar sign at the end, and it'll have to match that whole thing. So here we see some text and using the caret and the dollar sign where it doesn't exactly have the match because there's only 2 Z's. It doesn't end in 3 Z's. But here in the last example, you can see it's matching from the beginning all the way to the end. In fact, I wish I had done one more example, which is just caret and dollar sign, except grep doesn't show anything. That's how you can match a blank line. Question in the back.
That was my question. You just answered it.
Oh, okay, great. I think I might have been anticipating. Yeah, as I looked over my slides this morning, I'm like, oh, caret, dollar sign, I forgot that one. So, yeah, caret, dollar sign is great for matching blank lines. Or if you do like grep dash V and then caret, dollar sign, lines that are not blank. Okay, so I want to talk about the different types of repetition that are available. We've seen in the basic regular expression the asterisk where it can be 0 or more of whatever the previous character is. You could also do that with the curly braces. In basic regular expressions, you have to put a backslash in front of the opening curly brace, and then you have how many times you want it, and then a backslash before the closing curly brace. In the case of the asterisk, it's 0 or more, so the expression would be 0, comma. At minimum, we have 0, and we could have more than that. In order to use a plus in a basic regular expression, you have to put a backslash in front of it. And basically that means one or more of the previous item. The question mark is an optional item, which you can think of the previous character either appears 0 times or it appears 1 time. And I'll have a good example with both plus and question mark coming up. Sometimes you want to know an exact number, so you can just specify that number, like 5 matches or 3, whatever it is. You can do that number, comma, to mean that many or more. Or skip the starting number and up to, but not more than, a certain number. As well as you can do the entire range, kind of like the question mark, but I can specify 1 to 3 matches or however many I'm looking for. Now, extended really isn't a whole lot different. It's just that we don't have to put backslashes in front of plus, question mark, or the curly braces at all. And as I said, we'll be seeing some examples of these coming up in the slides. I just wanted this nice little summary table of all the different kinds of repetition that you can use. So here we're seeing the asterisk with 0 or more of the previous item. So we have A, B, Z asterisk, which means an A and a B, and then 0 or more C's, or Z's, excuse me. Which you can see in a basic regular expression, just using ordinary grep here, A, B, Z, backslash curly brace, 0, comma, backslash curly brace. Same thing as the asterisk above. I know it seems kind of ridiculous to put all this instead of one character, but I wanted people to really understand how those curly braces can work for them in basic regular expressions. So blah, 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 you could do like 3 in the curly braces. So you'd have like blah, and then curly brace 3, curly brace. Of course, if that's a extended regular expression, you'd have to put backslashes in front of the curly braces. Which you can see, and you're kind of close here, we've got 0 or more with an extended regular expression here. Notice there's no backslash because I have grep dash capital E. It's telling grep to use extended regular expression mode. Now the dangerous thing about asterisk is people do stuff like Z asterisk. What does that really mean? 0 or more Z's. That's always going to match. And you can see it matched there. There's exactly 0 Z's there. There's 1A, 1B, 1C, and 0 Z's. Okay, it seems to lag sometimes when I click. Then it takes me 2 bullet points ahead. Which I think I already just explained both of those, the basic versus extended, and that a single item followed by an asterisk will always match. You generally want to avoid that. Use a plus instead, because normally you're looking for 1 or more. And then to match the asterisk itself, notice that you could put a backslash in front of it. So we have a matching asterisk in our text. So now we're going to look at that plus, which is the 1 or more. You have to do a backslash in front of it in the basic, whereas in the extended regular expressions, you can just use the plus directly. So in our examples, we do see grep with ABZ backslash plus. And so it matched 1 or more Z's, it actually matched all 3. And instead of using something like that Z asterisk as Z plus, what had happened there? Well, it matched the plus literally because there is no backslash in front of it, but we're using just grep, so it's not interpreting the plus as a regular expression character, it's interpreting it as a plus. So you either need to put the backslash in front of it if you're doing basic, or do extended, and then you don't need the backslash. So here in our other example with grep with a capital E, Z plus works as expected. Notice it matches the Z but not the plus, or multiple Z's. And keep in mind this is basically the equivalent of those curly brace examples of one or more. So in a basic expression you'll have to have the backslashes in front of the braces and the 1 comma. And in extended you could just do Z, curly brace, 1 comma, curly brace to mean one or more. And as we did see in the second example, in basic regular expressions, the plus will just match itself. If you wanted to use an extended regular expression to match a plus literally, you can put a backslash in front of it then, which I don't have an example of, but here we see the question mark with the optional character, or 0 to 1 of that. In basic regular expressions with grep, you'll have to have a backslash in front of it. Extended, you won't. And so 0 to 1 of that previous character. Otherwise, if you're doing basic regular expressions, the question mark will normally just match itself. And extended, you can have it be matched if you put a backslash in front of it, which I guess I do have an example this time of something like that. But you can see here one way that you might look for alternate spellings of the word color. Color might sometimes be spelled C-O-L-O-R or C-L-L-O-U-R, depending on whether you're here in America or from Great Britain or something. So we have either the backslash question mark in a basic expression, or no backslash in an extended one. And you can see that it matches color no matter which way you spell it. Because you either have 0 U's after that O, or you have 1 U after that O. In basic, you can match that question mark itself, and extended if you put a backslash in front of it. And again, this is 0 to 1 occurrences of that previous character. The parentheses will allow us to perform groupings. In basic, you'll have to backslash these to create these groups of characters. The parentheses specify the group of characters that will have a certain number of repetition. Also, when you start using things like Perl and Python, the parentheses will specify the text that you want to extract, or the information in a group of characters that you're interested in. Of course, in the extended regular expressions, you don't need to put the backslashes in front of the parentheses. And again, we'll be able to use that for repetition. So instead of just a character repeated 1 or more times, we have this group of characters, A, B, C, that are repeated 1 or more times. And I guess this would be another case where blah, blah, blah might work, because it would match either a blah, blah, or a blah, blah, blah. Or as many blahs as you want to throw out, 1 or more. Just 1? Well, you can do curly brace, 1 curly brace, so it's exactly 1 blah. Yeah, I thought about talking about greedy versus non-greedy. I had to keep this talk under an hour, though. But I'm going to bring this up. Yes, it actually might end up matching them all, because regular expressions are very greedy by nature. I guess they're like people. I don't know. they want to get as much as they possibly can get to end their matches. And so one or more, well, okay, let's do one or more here, one or more here, one or more here. It's not just going to stop at the first one. Or just one, yeah, you've got that one character, but it could be there, that one character one time, again another time. What you'll find is that by using that question mark after them, they become non-greedy. So let's see if I can pull this out of the top of my head here. So we're looking at something like echo, quote, blah, blah, blah. And first we'll be greedy by grepping for that group. Is that a parenthesis? Blah. Repeated. Oops, this is basic. One or more times. Oh, I got an extra space in there. Yeah, it would find two because the first one doesn't have a space in front of it. What? What did I do? Well, I actually think I do. Oh, right, thank you. That's what it is. Yes, it is. But when I really want to get serious with my regular expressions, I go to Perl, and then Perl doesn't really differentiate between basic and extended, and you don't have to worry about all those backslashes. In Perl, the only time you use the backslash is like escape the meaning of the next character. So it simplifies things quite a lot. Although, yeah, you also have backslash named characters. So there's all three, blah, blah, blah. Now that didn't work. I think when I'm not looking over my shoulder, let's take this offline at the end. Okay. I mean, I'll go over this at the end. I see.
Space the question mark inside of paren after blah, and that got all. You know, like empty space question mark. So either.
Yes, sir.
I think because it's greedy, it's going to always try to go across. But if you put the caret, and just so you get to the leading one, I don't know if that means all wrong.
Well, I guess the other way that I could really go to keep this, that's one or more. Is that right? Exactly one. So yeah, exactly one, and you see it actually still got all three because, again, of its greediness. It's one here, and then one here, and one there. Again, I'm going to take this offline at the end of the class. It's so hard to type over my shoulder. Okay. Normal, basic, regular expressions, the parentheses can match themselves, as you see here. Where I don't have the backslash and I'm just doing basic, it'll actually match the parentheses. The vertical bar will allow you to perform what's called alternation. I kind of think of it as like a logical OR. It is an extended regular expression, so if you do grep with the dash E, you can go look for either A, B, C or X, Y, Z. And you can see how that would work. In doing an extended regular expression, we can see we could put a backslash in front of it so that we can literally find the backslash. Otherwise, in your basic regular expressions, if you don't have a backslash in front of it, it will be just treated as that literal pipe character. It's kind of nice for that logical OR business. Now let's look at some examples. Here's a Perl regular expression. With Perl, we've got some special characters. Somehow my slides got moved too. But, so, let me go forward and I'll come back. Okay, so I mentioned backslash isn't necessary in Perl to protect expressions that might be basic, but it does have a special meaning of escaping those characters that are regular expression characters that you want to just literally match themselves. But we also, instead of having named character classes, have these character sequences, like backslash lowercase w will match any alpha, numeric, or underscore character. Now when you see these backslash sequences in Perl, the uppercase version is just the logical opposite of the lowercase version. So kind of the mnemonic for backslash lowercase w is a word character, whereas capital backslash is not one of those word characters, alpha, numeric, or underscore. Backslash D will let you match a digit, and of course capital D not a digit. Backslash S is a white space character, so we're talking spaces, tabs, new lines, and then of course we have not white space with capital S. We also have something kind of like white space, but it also includes punctuation and line termination, either the beginning or ending of a line, I should say, and that's what they call a word boundary. So if you do something like backslash S, what, backslash S, you're looking for the word what with space around it. But what if what is at the beginning of the sentence, or at the end of the sentence, or has a comma after it? You wouldn't find it with that. But if you do like a backslash B, and then what, backslash B, now what could be at the beginning of the sentence or the end. It could have a period, a comma, a question mark, or whatever after it. As long as there's a boundary of that word with the rest of the text, then it'll be able to match. And this is one of the things that we kind of emphasize in our Perl courses, is like the difference between using backslash S and backslash B. Most of the time, you really want to just find the boundary of the word, because you're not trying to match that space or tab or new line character. You're trying to find what's inside of it. All right, so now that we are familiar with these Perl character sequences, let's look at that Perl example again. So we might have something like this: caret backslash D, curly brace 5, parenthesis, hyphen, slash, backslash S, parenthesis, question mark, backslash D, curly brace 4, parenthesis, question mark, dollar sign. Already probably people are going, whoa, I can't do that. It's really not that hard. You just kind of parse it left to right, and when you come into those parentheses, realize that that's going to be a group. Well, let's tear this thing apart. So, of course, the caret means this got to start with, okay? That's at the beginning. And then backslash D, curly brace 5, curly brace means exactly 5-digit characters. Which what we're talking about here is a postal code. So you can see just using like 92107, and in Perl, equal tilde is how you do a regular expression match operation. Typically, we delimit the regular expression with slashes, not quotes in Perl. So doing caret D or backslash D5 dollar sign would match 92107. Because this Perl statement will only print the word matches if this expression matches your regular expression. Or I should say, if this text matches your regular expression. Where you can see I would have 6 digits, Perl isn't so greedy there. It would only, would see, actually, because I specified from the beginning to the end is exactly 5 digits. It's not going to match it when it's 6 digits from the beginning to the end. So it didn't print any matches there. Now looking further, this next pair of parentheses is an optional group, because we have a pair of parentheses and then a question mark. And actually there's a second pair of parentheses and a question mark here. So optionally, we might have a 4-digit suffix to our postal code. And then optionally, before those 4 digits, we might have a hyphen or a white space character. That's there, the hyphen or the white space character. And then we have exactly 4 digits for that optional group. So you can see in the third example, where we've got 92107-1234, that does match this whole thing. But this other one, where instead of having a space or a hyphen, or a tab, I have an X, that doesn't match. Using a space also matches, because I could have either the hyphen or the space, some kind of white space. Yes?
That tilde, equal tilde, that's the shell script regex operator. What style of regex does bash by default?
Well, this is actually Perl.
Oh, it is? So
Yeah. And if you wanted to kind of play around with Perl, one of the nice things about Perl is you can go into the debugger. It's not like you can get a normal Perl shell, like you can get a Python shell or a Bash shell, but Perl does have this debugging mode where it is like interacting directly with the Perl interpreter. So if you do Perl-D, and it puts it Perl into a debug mode, normally you would go specify a file name after that, and then you can like step through with your debugger and do all the debugging of your file. But you can also have Perl debug expressions. E1 is just an expression, kind of arbitrary, whatever, in order to give the debugger something to work with. So if I were to go over to his thing, do you think Perl's installed on this Linux box? Absolutely. Absolutely. You can't really get a Linux install without Perl on it. So Perl-D-E, boom, I'm in. And so now I'd be able to interact with this thing like we see here. Print, quote, whatever you want, matches, if, and then you could do your parentheses, whatever your text is, quote that, equal tilde, and then typically the slashes around what your regex is. So I might just do caret \D curly brace 5, and then close parentheses. Does that look about what we had before?
Yeah.
Okay. And so we do see that that matches. Yes, he's got up arrow functionality working. Sometimes in Perl, that may not work right out of the box. There's a Perl module, I think it's the term read line module you have to have installed, or else you can't do up arrow in the debugger. But that makes it a lot easier. If I were to try and say, does that match 6 digits? You can see it does not print matches, because that is false. It doesn't match 6 numbers. So there's a Perl example. You don't have to do anything in Perl to make that functionality of regular expressions available. You can just start using them out of the box. In fact, when you start working with the default variable, it automatically is ready to do matching against the default variable. And you don't even have to use the equal tilde at all, which is kind of an advanced thing. Oops, I was right where I wanted to be. So let's say I'm going to assign my default variable a value. Oops, that's supposed to be $_, which Perl just kind of magically assigns things to $_, like when you're in a for loop or something like that, what you're iterating over will automatically be assigned to $_, and then you can check to see what if it matches or not. All right, so I'm going to make that my 92107, and then I'll do something similar to what I had before, but print that if matches or if, and I'll just do /D 5, whoops, curly brace 5. Okay, so we have our regular expression between the slashes, the \D for the digit, and 5 characters. I already assigned something I'm going to be testing. Instead of having my literal text here, I've put that in the $_ variable, or the default variable. And that means to Perl, it's going to be testing that with regular expression matches by default. You don't even have to use that =tilde operator. And you can see it performed the matching operation. Now, some people like that about Perl. It's very convenient to write code where you don't have to explicitly assign things to a variable. Myself, the first time I got into it, I was like shaking my head like this guy, going, what happened? What's going on? But, you know, there's a difference between code that you're going to write and you're going to maintain over a period of years, and then there's the code that you just need to make it run today to pull out those email addresses from that document, and then that code gets thrown away tomorrow. And that's where I see this kind of code as being good. Go ahead and use the shorthand techniques that are available. Whereas if I was going to want to maintain this over a period of years, I'd write it out the long way, so that someone who comes later won't be going, well, what is it matching against? I don't see what it's doing. So, anyways, we already talked about the Perl character sequences. We also have an example here with Python. I guess I should back up a little bit. So I'm going to start off with this regular expression. So here we have parentheses, mail_to, pipe, parentheses, news, pipe, parentheses, HT, pipe, F, parentheses, TP, parentheses, S, question mark, a couple more parentheses, a colon, 2 slashes, a parenthesis, and then curly brace 1. And again, you look at that the first time, it's like, wow, that's kind of hard to process. But if we look at the outer things going on there, we've got a parentheses where we've got exactly just one of these things that's in that group. The first one thing that might be in that group is mail_to. And then we have that vertical bar, or that we're using to separate the alternatives. We have, and then fortunately it didn't line break like it did above, either news, HTTP, FTP. See how that works? We have either HTTP or FTP, as well as news. And then an optional S added to the HTTP or FTP, because we might have HTTPS or FTPS. And then, of course, we just have kind of the literal : / that gets added to those types of protocols, whereas the mail_to protocol doesn't. And I don't know why my slide seems to be condensed there. How hard is it to start a Python shell? By the way, getting out of Perl is just Control-D. And do you think Python's installed on here? This is a Fedora install. Oh, absolutely, because Red Hat does all of their system tools. Anaconda, the installer, is written in Python, amongst many other, like system config users or system config printer or whatever it is. So there you go. You can start up a Python shell. Now, unlike Perl, regular expression functionality is not going to be right available immediately. You have to import RE. RE is the regular expression module. It comes with Python. You can do help paren RE paren after doing an import in case you want to know more about how to use this module. It'll give you full documentation of it, even show you all of its regular expression characters. And notice they show the dot, the caret, dollar, asterisk, plus, question mark, and then they have those things in their non-greedy form, which, remember on the command line I was trying to add that question mark? So asterisk question mark is a non-greedy form of the normally greedy asterisk, which will keep matching and matching as much as it can. There's the non-greedy form of one or more, and the non-greedy form of the optional character. And you still have all those curly braces and square brackets, as well as alternation with the hyphen, the parentheses for your groupings, and more. As well as different functions that are built in, and different options, like he mentioned multi-line mode, and how that can modify things. And it even gives you the full documentation of that. This Q is kind of like a man page, the help for the modules. And then you can see the code up above, where I create a regex object by using re.compile with my regular expression. So that gives me this thing called regex, that when I want to see if something matches, I use regex.match and whatever text there is. That will be assigned to something called a match object. If you have a match object that's not null or none, then it could print out that group of text that it matched, and that's where those parentheses are good for extracting your data. Otherwise, if there's no match object created, then it really didn't match your text. And you can see where I've done an example here using this little protocol function I defined to see whether a protocol gets extracted or it shows no match. Oh, I'm sorry. I forgot I was on that. So here we are where I'm talking about this stuff here. The regex object here equals re.compile function is where I have it create this regular expression object. And then with that object, it's got this method match to see, and it will return true or false, but if you want to know what you matched, then you want that match object where you can print out or work with match object group to see what was matched in that group that you have. And you can see when I call that function protocol with like HTTPS, it took that text, it found the match object, and it printed out HTTPS : the part of the regular expression that actually matched in this text here. Whereas if I use something like TCP : well, that was nowhere in my regular expression, so there's no match. Okay. Any other questions on that? Does that help? Okay. And one more recommendation for you. You might want to check out this site, regexlib.com. Oftentimes when I was talking with my students in class, I'll send them here. Go check out that library. It has a nice cheat sheet kind of summarizing the different items that we talked about today for those regular expression characters. It also has this little interactive tester where you can put in your text that you're trying to work with, and then another area where you can type in your regular expressions and then click a button to see if it's matching, what it's matching, and all of that. And then finally, it allows you to search through thousands of these already created regular expressions. It's kind of amazing somehow, or how complicated these sometimes get to be. Like you'd think, oh, a valid date. Not too hard, 2 characters slash 2 characters slash 4 characters, or digits maybe. Well, it gets a lot more complicated than that when you try and figure out what days are valid within January versus February, and what years are leap years and not leap years. They have this one valid date regular expression, I swear, it must be 200 characters long, but it will match any date at all from the, BC to the current dates, do leap years, correct number of days in every month. So why would you want to spend probably a week on trying to create something like that yourself, when you could just go copy and paste that out of the regular expression library right into your code, run it through a few tests, make sure it does what you want it to do, and boy, have you saved yourself a lot of time. There's no need to reinvent the wheel, is what I would say. Uh-huh.
Is there a way to summarize the purpose of look-ahead in a brief way?
Looking at what?
Look-ahead operators. Is there a way to summarize that? Because that's the only part of regex that I'm not used to.
Okay. What he's talking about is these expressions that you can add. It's kind of like a conditional added onto your regular expression. Because normally we might have an expression, let's just keep it simple, quote ABC, quote. Well, we in a sense have like the look ahead with the $sign. If you have ABC $sign, means I want to match ABC if it's at the end of the line. Well, instead of a dollar sign, you could have after that ABC a look ahead expression where if it's followed by DEF. So we can match ABC only if it's followed by DEF. Yeah, so it's just a conditional kind of thing that gets added. You can a really good page for that. Or I hope John doesn't mind if I go try and launch a browser. I don't know. Perldoc.perl.org is a pretty good place. If you go to the Perl regular expression page there, I think it's perlre.html at that site. They have a good explanation of the look-ahead operators. But in our own advanced Perl class, we go into that as well. Which is funny, we end up kind of talking about Perl at the beginning and the end. Here's another XKCD slide. Whenever I learn a new skill, I concoct an elaborate fantasy scenarios where it lets me save the day. Oh no, the killer must have followed her on vacation. But to find them, we'd have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. Everybody's staring back. I know regular expressions. And come swooping in, Perl. Saves the day. Gotta love their humor. Which, at my GitHub site, which at github.com/WrightRocket, I just recently posted something I wrote in Perl. Started it over Christmas vacation as I had recently got this NAS device, and I was trying to consolidate all my photographs and images onto this thing. from multiple computers. It was kind of a difficult project, but I ended up using Perl to do it. Lots of regular expressions are involved. It's at github.com/wrightrocket that you could go find that. And very soon I'm going to actually be posting a deduplicating Perl script that I wrote too, because now that I've got all these pictures there, some of them have different names that are stored in different places, but they're really the same image. And I'm going to be using Perl, and I'll have a good script where it goes and analyzes the file and compares really the contents of the files and then deduplicates for you, not just on file name, but actual file content. So I do find Perl very helpful for saving the day.
On a side note, I think you can do that with rsync as well.
To some extent you can, but there's some interesting things that I did with it, and I didn't just consolidate them. I actually used the XIF tool to extract the data information from the photos, and then I organized them by year, month, and day. So that now all of my photos from like 2001 through 2014 all have their own day that they're in. So if I'm trying to go browse through them and something, I don't end up seeing 35,000 photographs in one folder, and my program goes, Now if there's 20 or 200, it'll read them and process them fine, but when I get 30,000 in one place, it's just a nightmare. So anyways, this is my last slide where, again, I want to kind of promote our own courses here at One Course Source, where I've been an instructor now for the last 8 years. We do have online public classes, Linux, Perl, Python, security classes. We also do custom corporate classes, and we'll even do a class for whatever you want to do. I'm developing a custom Python course for Qualcomm right now, where they're using Python and Garrett code review along with GitHub, and I'm integrating this all together and showing them how all that works. So if you want to develop custom training, let us know. Come up to me, or you can go contact me. I thought it was on the slide, Keith at, somehow my resolution, I think, being so low, it's not showing it. It's Keith@onecoursesource.com. Or you can just Google Wright Rocket. I've got lots of sites out there, GitHub, Blogspot, even wrightrocket.com, I own that domain. Yeah. Any questions for me on anything that I've covered? I think the gentleman who was asking the blah, blah, blah question walked away, but well, thank you all for coming. It looks like I actually did keep my presentation about an hour, but because of the late start with the projector difficulties, it looks like we kept you a little late. I hope you have a good afternoon, and come stop by the booth out there. We've got One Course Source right in the middle between the two main halls if you want to get some good swag or find out more about our classes. Thank you, everyone.